Hi, good afternoon, everyone. It's a pleasure to be here. I'm delighted to have been invited. I struggled a little bit with what to talk about today, but I've decided to talk about a couple of studies that I've worked on in the recent past that aim to understand and improve the usefulness of travel demand models for transportation equity analysis. I've been interested in equity since my grad school years, and I just wanted to remark on just how much the literature and the minds that are focused on this topic has grown exponentially just in the past 10 plus years. So it's a good time to be thinking about and asking these questions and working in the equity space. Today, my talk is titled Toward Equity in Travel Demand Modeling. My training is in travel demand analysis, and my interest is in improving them so that we can better understand the distribution of impacts from transportation infrastructure and policy improvements. Um, I am here at UCLA. I forgot to mention. I'm in civil and environmental engineering here at UCLA, and I also have a split appointment in public policy. And so a lot of the work that I do is kind of trying to understand more of the application side. How do we apply these techniques? How do we improve, standards and practices for travel practitioners? Okay, so here's the outline of my presentation. I'll talk about some motivations. So what has inspired me to work in this area? I didn't know, how familiar the group would be with travel demand analysis. So I have like a really simple primer that I'll give. And so it'll certainly be a review for most of you, but introduction to some. I'll talk about the two examples of ways that I think that we can advance equity or improve the tools for doing equity analysis, and then summarize from there. So my work is motivated by the historical examples that we have of how the costs and benefits of transportation infrastructure can be distributed in different ways, in unfair ways, and the legacy of decisions being made without recognition of the fact that communities will be impacted differentially. So this is an example picture here, the community of Black Bottom in Detroit. I happen to hail from the city of Detroit, Michigan. And, as many of you all might be familiar, the construction of the Eisenhower interstate system had the impact of displacing lots of Black and minoritized communities. So the right-of-way that was purchased for the expansion of the infrastructure was often taken from lower-income communities, and it had detrimental effects. So at the same time that the United States government was investing hundreds of billions of dollars in expanding accessibility in this country, those who paid the costs were most likely to be the most vulnerable members of our society. So this is a before and after picture. And this is the same case, but I wanted to, on a personal note, just share that, this case in particular is not abstract to me. So these types of issues, the impacts that transportation can have in a harmful way is not abstract to me. So my own family were impacted by this particular case. This location here in Detroit, this is St. Jehoshaphat's Catholic Church, and there are many stories passed down where my grandmother would say when she was young, she could look through her window and look into the sanctuary of St. Jehoshaphat's Church. And so we know that she must have lived somewhere here. And so this is sort of the before and after picture. And the point is that, these stories are still very much part of the living memory of many community members. It affects their decision making. It affects the trust that they have in these planning activities. And so it's really important for us to remember that, there's a connection between these historical decisions that have been made and today. So these impacts still resonate today. Here's another example of the community of Rondo in St. Paul. So similar to Black Bottom, the community of St. Paul was essentially sliced in half in order to make way for this stretch of I-94. And the reason why I highlight this example in particular, because it's one of the ones that we see where there's still active projects going on to reconnect this community and address what was a past harm. And so there's an organization called Reconnect Rondo. They've been successful in lobbying for funding to do studies. They're advocating for funding to do a land bridge cover over 94, and they were recently awarded funding from the Reconnecting Communities discretional grant from DOT. So there's a lot of active work in this space, and I've done some writing on this, but I think it's just important to highlight that there's this connection between past decisions and opportunities to, every year, opportunities to address these harms. Also, what motivates my work is not just the historical picture, but the fact that these inequities still persist today. So here are a couple examples. If we look at some of the recent studies using data from Uber and Lyft, it's been found that Black and minoritized travelers tend to experience significantly longer waiting times due to higher rates of cancellation among Uber and Lyft drivers. If we look at the total amount of transit spending in the United States, there's a lot of evidence to suggest that vulnerable travelers tend to benefit more so from improvements in bus transit services, yet the lion's share of investment still goes towards heavy rail construction. And then, there's a whole lot of investigation into, differences in how we travel and how we make use of the transportation system. And we know that vulnerable travelers tend to travel less, yet they are most likely to experience harm in the form of air pollution and noise pollution as a result of transportation infrastructure, construction, and so forth. So these types of inequities persist today, and every year there's an opportunity, as we invest more, there's an opportunity to do better and to consider these types of potential outcomes when we're making decisions. So the next thing I want to do is talk a little bit about travel demand models, and they do play a central role in transportation planning. If we think about the totality of spending in the United States for transportation dollars, there's a huge potential for these tools to be used to guide those decisions. These are large-scale computational models that are often used in mid to long-range transportation planning activities. And they can be used to decide on or against large infrastructure. So think about, extending, like the extensions to light rail that LA Metro was making here locally. I'm going to sort of skip over sort of the arguments that we're having around shifting from more traditional four-step models to activity-based models. But the point here is that these are tools that are intended to break down all of the different types of transportation decisions that we observe in the network. So think mode choice, destination choice, and increasingly so things like residential location choice, also auto ownership and work location. So all of these different types of transportation-related choices, we're breaking them down into choice dimensions, and we're seeking to model them using behavioral models, so using discrete choice models. And they take in information about the population and economic forecasts on where the businesses will be located in the future. And we can gain information about level of service changes over time, accessibility changes over time, and so forth. So each of these components are often modeled using discrete choice models. And so this is my little, 4-page primer on discrete choice analysis. So discrete choice models, they find their roots and foundations in consumer theory. And so the idea is that if consumers are faced with a set of alternatives, the assumption is that they will assign some benefit, some utility to those alternatives, and they will seek to rank them according to their preferences. And we as analysts, what we're trying to do is to model those preferences and the preference structure using mathematical formulations of utility. And those functions, those utility functions, are a function of the attributes of the alternatives. So if we're talking about mode choice, we're talking about things like time and cost. Characteristics of the individual are really important. So as we've been talking a lot about today, the choices that you make will be based on what your needs are, how you need to use the transportation system. Also things like household structure, Important characteristics that that map to how you make decisions about transportation alternatives. And then we also recognize that we as analysts cannot predict everything deterministically about travel behaviors, and so we have this random error component that reflects the unobserved factors. So we make some assumptions on how people are arriving at decisions, and we use utility maximization. So we select the alternative, or the individual chooses the alternative that maximizes their utility. We make an assumption on the distribution of the error term. This is a random error term, and so I won't get into this. There have been decades of proofs on what this distribution should be, and we use extreme value distribution in the case of logit. So with those assumptions, we arrive at a function for calculating the probability of a choice. And the way that information enters into that choice probability equation is through these utility equations. And so we have our data that represents the information about the alternatives and the characteristics, and we estimate the parameters based on those data. Now, the point that I want to make here is that if there is imperfect information, if the data, the X's are skewed in some way, potentially because there are groups that are statistically missing from the data, then this affects our estimates of utility, and it also affects the model structure, and ultimately affects our estimates and evaluations of the impacts of transportation infrastructure. And so this is really the primary motivation for the couple of studies that I'll demonstrate to you. So next, I want to use this slide to summarize the general phases of the travel demand analysis process, but also talk about sort of my frame of reference in thinking about equity in transportation and travel demand modeling. And when I started doing this research, I started all the way down here. So we have data collection. We clean that data, we process it, we expand it using sample weights or data correction approaches. We use that data to model and do scenario analysis and predictions, and then we calculate measures to inform decisions. And so with respect to equity, I was grappling with questions of how do we use travel demand models to perform equity analysis? What measures do we use? How do we do the comparisons? Let's take a look at what is done in practice and try to do better. And I noticed a lot of the same things that that you all have noticed. So Amanda talked about the prevalence of using location-based analyses for transportation equity analysis, where you ascribe benefit based on proximity and things like that to infrastructure. But the reality is that that's not sufficient for capturing how people are impacted, how different groups are impacted by transportation infrastructure, how they benefit and the costs that they pay. And so my work in this area has been focused on how do we make better use of these very sophisticated activity-based models that we have at our disposal to do more fine-grained analyses, look at distributions of outcomes, look at individual indicators of transportation benefits and how they are distributed across the population. So I've done a lot of work there, but what I recognize through that process is that we are hyper-focused on measures. And even today, a lot of the study is, the focus on equity standards and principles is still in its infancy, I would say. Like it hasn't really become a part of how we do equity analysis. And so we're hyper-focused on equity measures, but those measures are only as good as the data that we have, the models that we're using. And so my attention turned to data and data quality and asking questions about the survey data that we use for model development and what that means. And that's what I'm primarily going to talk about today. I'll focus on data collection, and I'll focus on some ideas for,
Go back one slide just for a second.
Yes.
Thank you. Just to take it all in.
Awesome.
Thank you.
So that's what I'm going to talk about today is one study that kind of grapples with representation in household travel surveys, and a second study that is sort of the next iteration of that is so what next? What are the implications for how models might change if we have better data? So I started to look into what we know about representativeness in household travel surveys, which are still the primary data source for estimating regional travel demand models and also doing academic studies. And there are a number of ways that conventional household travel surveys might be biased or cause us to question representativeness. So we know that there can be non-coverage issues where certain communities or certain persons are not in the sampling frame. We know that there can be non-response issues. So these are people who are in the sampling frame. We know who they are. We have a means of reaching out to them, but they are not responding for whatever reason. And that can be thought of in terms of unit non-response, where the individual is not responding at all to the survey, or item non-response, where the individual is choosing and selecting what questions to respond to and tend not to respond to questions about things like income and race and location-based questions as well. So the other thing that we're finding is that there's a potential for there to be a mismatch between the way that we're retrieving the data. So the survey modes that we're using, and I'm pointing to issues related to the digital divide, where we're seeing increase in the types of surveys where we're doing online surveys and things like that, but that can be a mismatch with respect to individuals that might have literacy challenges or might not have access to or easy access to an online survey. A couple of other notes from this literature review is that we know that certain types of sampling errors are more likely among disadvantaged communities. And we know something about the types of solutions. So there's a lot of emphasis on increasing sample sizes and more sophisticated data stratification. The sample size thing is one of the reasons why we're seeing a lot of attention towards big data and trying to make better use of passive data, and that comes with its own challenges. But nevertheless, we do have some idea of ways of improving survey error overall. Nevertheless, it's unclear how to get better representation, how to even think about how well surveys represent certain groups, as opposed to relying on things like sampling rates as a measure of the performance of the survey. So to understand the severity of the problem, what we did was to develop what we refer to as a group representativeness ratio. And this is a measure that we are seeking to use to evaluate and compare representativeness across multiple surveys. And the idea is that we can use the sample weight as a measure of distortion. So it shows how far the population statistic is from the sample statistic for a subgroup. And the larger the sample weight, the indication is that the greater the degree of distortion. So what we can do is we can take the median sample weight for a disadvantaged group, and we can do the same for a more affluent group, and we can take the ratio and compare, and that will give us some measure of the degree to which the disadvantaged group is reflected in that particular survey relative to the advantaged group. So we apply this measure by comparing 42 different household travel surveys across the United States. And so we sort of painstakingly collected and processed and also computed some more qualitative indicators about how the surveys were collected and what the strategies were and so forth. But we applied this measure, and we also applied it across different domains of disadvantage. So we looked at things like low income versus high income, zero vehicle households versus households with at least one vehicle. We looked at Black heads of household versus white heads of household, and also unemployed versus employed travelers. And what we find is that there's a range of performance, but overall, the majority of surveys are not reflecting these disadvantaged groups particularly well. We found only 11 out of 42 represented all groups reasonably well, so within this range. So that's about 26%. And we also tried to tie this to, tried to understand the reasons under this. And so we looked at the different ways that these surveys were collected. We looked at things like what was the sampling design? And, did they use different types of stratification approaches? What were the survey modes that they offer online versus GPS versus paper and cellular-based survey options? We also looked at things like what was the sampling frame? Was it telephone-based sampling frame? Was it address-based? Was it something that was a mixture of more innovative approaches? And so we did a simple k-means cluster analysis, and what we found is that the surveys that tend to represent disadvantaged groups better are surveys that they offer a mixture of survey modes, and they also offer an option for the individual to choose how they want to participate in the survey. These surveys also, they also offer things like a hard-to-reach incentive, so they're more likely to offer an incentive, and they're more likely to offer a higher level of incentive. And they're also most likely to offer GPS retrieval in addition to other survey modes. And so, so the takeaway here, or things that we're thinking, is that we do have some idea how to do better. But the reality is that for the majority of surveys that we're still using to support model development, we're not performing very well. Yes?
I have a quick, could you repeat the definition of the ER ratio?
So we're calling it the group representativeness ratio. And it's a simple ratio of the median sample weight for a disadvantaged group versus an affluent group.
It's a sample weight, okay.
Yes. And I'll point out that it's an internal measure. So we're not comparing the sample weight directly across surveys. We're comparing the sample weight internally for a single survey, and we're comparing the ratio across surveys. Okay. There's a second. Yes.
Yeah, I guess this is related. So I was wondering what is the ground truth here? Can you explain that? Because I assume you're comparing what you see from each survey to something, right? There's a benchmark. So what is that benchmark? I guess I'm missing that.
So if the ratios are near 1, then that means that the representation of both groups is similar. Okay, so there's no sort of imbalance, but there is no true ground truth here, because it would be useful to be able to say what is what level of a sample weight might we have more confidence in, something like that. But that's something that we don't have. So we're just comparing across the groups to take a look at how much better is one group represented compared to another.
But I would say implicitly the census is the ground truth, right? Because you sample.
The census has similar issues. So if you look at the margins of error that are produced with the census, we've actually currently doing a similar study using the American Community Survey, and the results are pretty similar, right, with respect to the level of margin of error for places where you see high density of disadvantaged communities versus affluent communities.
And my follow-up question would be, based on what do they decide about the multiplier?
So it's not a sample weight, it is a margin of error that they compute based on I think a 90% confidence. So they do publish how they calculate their margin of error. So so the point is that that's a good question. It would be desirable to have such a question, but I think this is still really valuable in the sense that it shows cases where you have just super poor representation and overrepresentation of affluent communities in the survey. Okay, all right. So many of the surveys that we're using in practice today that are supporting development of trouble demand models don't represent disadvantaged communities well. And the question now is, what are the implications for these tools that we're using to evaluate transportation infrastructure projects? So in this next example, I'll talk about a study of travel behavior, trying to understand travel behavior and needs in the city of Benton Harbor, Michigan, which is a small city on the western coast of Michigan. This was a part of a larger NSF study where we were focused on smart and connected communities and how to equip under-resourced cities with better tools for evaluating transportation issues and making transportation interventions. And so as a part of that, we collected a small travel diary for Benton Harbor. And some of the context, Benton Harbor is one of the poor communities in the state of Michigan, where about 50% of the population living below the poverty line. And so with this study, we anticipated that many of the travelers would fall under this group of hard-to-reach communities and people who are least likely to be included in household travel surveys. And so we devised a data collection strategy that involved partnership with local organizations like Connexus, which is the career service provider, the local career service provider. We also partnered with Dollar Ride, which is their transit operator. And we worked with them to develop a mixed survey approach. So we developed a paper-based survey, an online-based survey, and we also had app and wearable tracking for passive data collection. An essential part of this strategy was also to accompany our survey with options to participate in a community workshop. And so this way we were able to bring people in. They had a choice to take the paper survey or the online survey. They could hear from the research team, myself and my students. We could assuage any worries that they had about the use of the data and the impact of the research. And we also learned quite a bit in this process of interacting directly with the survey participants. So there are lots of people who we had to, for example, we had to, triage different issues and barriers. We had to transform the survey into more of an interview where we asked the questions verbally and we recorded the information. And so I thought it was a really useful opportunity to understand in real time these types of barriers that might prevent participants from participating in data collection activities. So a little more about our method. So this was a targeted strategy where our intent was to oversample the most disadvantaged travelers. We did that using a mix of survey modes to target hard-to-reach communities, including low-income, transit-dependent, elderly, and un- or underemployed residents. We did this using a very creative recruitment approach. So we didn't have a traditional survey frame. We did things like distributed flyers to Connexus clients. We posted ads directly in the shuttles. We posted in the local newspapers, including local neighborhood circulars. And we also made announcements on radio stations. The participants were offered an option to participate via paper or online survey, and also, I don't have it here, but there was a smartphone-based app as well as the option to carry a wearable tracker for 1 week. So we had participants do that, and we offered community workshops. So overall, we were able to collect 331 usable surveys from this process. This is a small sample, but also a very small community. And one of the things that we observed here is that we think we were pretty successful in reaching the more disadvantaged demographic. And if we compare some information about their travel behavior, their mode choice, to the lowest income travelers based on the standard survey for the region, we'd still find some significant differences in their behaviors. And so 44 versus 66% auto users and a much higher share of transit users. So the strategy now is, or the question now is, what are the benefits of having this targeted data? and how might we use it to improve travel demand models and improve the performance of these models for representing these groups. And so our strategy is to do a combined or pooled data set so that we can do joint estimation of preferences and also investigate how these data might influence the structure of the model itself. So how do we actually do this? How do we go about combining these two data sets? Well, there is a well-established framework for jointly estimating utilities from multiple sources of data. I think the most common examples are of RP versus SP data, where we're trying to combine a survey that is revealed preference versus stated preference, or multiple revealed preferences for a same city. And so the assumption here is that we are assuming that these data are different data generating processes that can explain utility. And in technical language, what we're doing is allowing for the scale of our logit probability error to be different. We're allowing for that scale to be different. So we can jointly estimate a model from these data. But the first thing I want to show you is a simple nested logit mode choice models estimated from both data sources. So we have a model here that's estimated from our survey. We're calling it the travel needs survey. And then a model estimated from the MDOT household travel survey for the region. And there are many differences, but we can summarize these in terms of the value of time. So we see that the values of time are quite different for these two samples. Again, this is our value of time for the travel needs survey versus the standard survey. And sorry, I'm jumping ahead. So the some of the other differences that we notice are also the ways in which people use the transportation system. So for example, the tendency to walk for commute trips among the disadvantaged travelers. Now, once we estimate our pooled model, so we've done this joint estimation for from both of the data sets, we find a model that right, so we find a model where the value of time relative to our standard model is somewhere in between. And so the implication is that the preferences are different, and our understanding of how people are traveling is also different. So in this case, for example, we see that there's a tendency to use rideshare and dollar ride, which is transit, for healthcare-related trips. And so our understanding of how people are moving, the picture of that is different. Our evaluation of things like value of time and levels of sensitivity are also different. So the next thing that we look at is what is the influential model structure? And so often, I think what we've discussed in previous presentations in this seminar is that the standard is to use things like a nested logit. And so if we look at models that are in practice today at metropolitan planning organizations, we see nested logit and we don't see much of anything else. And so if we sought to measure preferences using a standard nested logit, we would get something like this, where we have auto modes nested together, so auto drive alone and shared ride nested under auto, dollar ride and bus nested together. And I think I failed to mention that dollar ride is kind of like paratransit in this case. So it's an on-demand transit shuttle, and then we have walk. But if we sought to estimate a nested logit using our travel needs survey, our picture of the error structures do change. So in the case of the travel needs survey, we find that dollar ride is perceived, there's a couple ways of interpreting this, but it's perceived more so as an auto mode than it is in transit mode for these groups. And the other explanation is that the things the unobserved factors are more highly correlated for drive alone, shared ride, and dollar ride than they are for bus. And so again, the point here is that if we're using data that is more reflective of the travel behaviors of disadvantaged travelers, we do get significant changes in the preferences as well as the structure of the model. And so the implication is that the ways that we are estimating benefits through utility might be quite different. And in some cases, we might be overestimating the benefits associated with a particular transportation project for disadvantaged travelers. Okay, so this is great because I feel like, folks are just taking it in and there are no questions. So I'm already at the end. So to summarize, I think that there's no single path to advancing equity in travel demand models. I think it is tied to the data. And with respect to data, we've learned that vulnerable travelers are often missing from household travel surveys. And I think that part of the solution is in more activities where we're fusing data together, where we're combining data sources to enrich them, such that we can generate better properties and understandings about the behaviors of these travelers. With respect to models, there are important implications in terms of if we have better data, the actual models that we're using will be different. The estimates of benefits will be different. We could be potentially, with the models that we're using today, we could be potentially misrepresenting the benefits of transportation infrastructure projects. Something about next steps. So I have a lot of next steps. This is ongoing work for me, but one of the things that we're interested in is trying to understand the impacts or the potential for different policy inferences. So will we actually arrive at different decisions if we have better data and if we have better model structures? Another thing that I think it kind of picks up on some of the other topics that we've heard is this notion of including race in travel demand models and statistical models. And the reality is that it's not just a simple exercise of including it. I think that we need to be careful in thinking about what we're actually measuring when we ask individuals about race, when we categorize travelers by race, when we do assessments and seek to include race. There have been several recent studies that have called for the direct introduction of race into travel demand models. And it can lead to problems, I think, for a number of reasons and that we can discuss. And then the final thing I'll say is that I'm really interested in this idea of choice set modeling. And so going back to one of the slides, maybe I should just do it this way. So going back to this slide, often analysts will assume that we can correctly specify the choice sets. In practice, we're making assumptions about what modes certain travelers have access to or what modes or alternatives individuals might have considered. But the reality is that we don't have great information about what choices travelers are considering. And in fact, many travelers are not choosing alternatives at all. They're constrained out of making choices. And so I'm really interested in the balance between choice making and constraints, how we reflect those constraints. And I think that that is really an important path to understanding or improving the ability of these models to capture real world constraints for travelers. And so that's one of the directions that we're moving into as well. So with that, I will close and I will take the award for fewest questions.